Hello, students. We often learn how to write and balance chemical equations, but that's really only half the story. Today, we're going to learn how to make our chemical equations tell the complete story of a reaction. We'll be adding some crucial details that make them much more accurate.
Okay, let's take a look at this equation together. It shows iron reacting with water. If we balance it, we get 3Fe plus 4H2O gives Fe3O4 plus 4H2. The number of atoms on both sides is equal, so yes, it is balanced. But is it really telling us everything? For example, is the iron a solid? Is the water a liquid, or is it steam? We don't know. So you see, even though it's balanced, it's not quite complete.
So, the very first step to making our equations more informative is to mention the physical state of every substance. That means for all the reactants and all the products. This is a very simple but a very critical piece of information.
For substances that are solids, we use the symbol S inside brackets. For example, if we are using a piece of solid iron metal, we would write its formula as Fe followed by S. Simple, right? And in the same way, for a substance that is a liquid, like the water we drink, we use the symbol L in brackets. So liquid water would be written as H2O with an L next to it.
And I'm sure you can guess the next one. For gases, like hydrogen gas or the oxygen that we breathe, we use the symbol G in brackets. This immediately tells us that the substance is in its gaseous state.
Now please pay close attention to this one. You will see it very often. The symbol is AQ, and it stands for aqueous. We use this when a substance is not a pure solid, liquid, or gas, but is actually dissolved in water to make a solution. This is very common in chemistry.
A very good way to remember this is to think of making nimbu pani, or lemonade. When you dissolve sugar and salt in water, you are making an aqueous solution. And many of the chemical reactions that we do in the science lab actually happen in these aqueous solutions.
All right, next, let's talk about the specific conditions that are sometimes needed for a reaction to happen. You see, just mixing the reactants together is often not enough.
It's really neat how much information we can put right on the reaction arrow. If we need heat, we can just write the word heat, or use this little triangle symbol, which is the Greek letter delta. If a specific pressure is needed, like 340 atmospheres, we write that value. Some reactions need sunlight, and others need a catalyst. That's a substance that speeds up the reaction, like chlorophyll in plants. All of these important conditions are written right above or below the arrow.
Okay, so let's put all of this together now and see how these details can change a basic equation into a complete and much more meaningful one.
Let's go back to our very first equation. Look at the after version. It shows iron is a solid, Fes. But the most important detail here is H2OG. That little g tells us that iron is reacting with steam, not with liquid water. This is a very important piece of information that was missing before. We also can see that the products are a solid and a gas.
And here is the famous photosynthesis equation. The before version is just a skeleton. But now look at the after equation. It tells us the carbon dioxide is dissolved in water, it's aqueous, and it's reacting with liquid water. And right there, on the arrow, we see the essential conditions, sunlight and chlorophyll. Without them, this reaction cannot happen. It's so much more informative now.
So, you might be wondering, why is all of this so important? Why must you include all these details in your exams and for your own understanding?
Well, the most important point is this. A complete chemical equation is a precise scientific statement. It doesn't just tell you what reacts, it tells you how it reacts, in what conditions, and in what physical state. It is an accurate description of a real-world chemical change.
And here is a very important tip for your exams. Often, marks can be cut if you forget to include these details, so please be careful. Writing the state symbols and conditions shows a complete understanding, so always try to write the full informative equation. Okay, so let's quickly summarize what a complete and informative chemical equation should have, just to make sure everything is perfectly clear. So just remember these 4 key things. First, the correct chemical formula. Second, a balanced equation. Third, the physical state symbols, S, L, G, and AQ. And fourth, the necessary reaction conditions written on the arrow. If you have these 4 things, you have a perfect chemical equation. Now that you are an expert at writing a perfect chemical equation, you are ready for the next step. You can think of these equations as sentences that tell us different kinds of chemical stories.
So, are you ready to explore the different kinds of stories these equations can tell? In our next explainer, we will use these complete equations to learn about the different types of chemical reactions, like combination, decomposition, displacement, and more. I will see you then.